All set?
Okay, welcome to this October 20th edition of the Materials Manufacturing Seminar. Just a couple of quick things. So next speaker is Matthew Earlham from Argonne National Labs. If there are any first semester students interested in please contact me. Can about that. With that, I'll go ahead and also mention today on a platform that doesn't need polls. So rather than attending, I'm just going to look to the participants list to and so you'll see there, one next name canvas. Okay, so I'll turn to Madison Rutherford, a member of the group. Is going to introduce. There we go. Who's going to introduce our speaker?
Alrighty. So today I'm really honored to introduce Tony Seba. He is a man with numerous titles. He is an author, educator, speaker, investor, and entrepreneur. I know many of us here have been following his work and are excited to have him here today. Mr. Seba received his Bachelor of Science in Electrical Engineering and Computer Science from Massachusetts Institute of Technology before completing an MBA at Stanford University. His work focuses on disruptive technologies. These are technologies that significantly alter the way industries operate. His work specifically focuses on clean energy, food and agriculture, and transportation. Mr. Seba has authored various books on the subject, including Clean Disruption of Energy and Transportation, Solar Trillions, and Winners Take All. He is also an educator and for years has worked as an instructor for Stanford, developing and teaching courses on entrepreneurship, clean energy markets and disruptions, and finance. He has been a keynote speaker on similar topics and has appeared in various documentaries and podcasts, such as Sun Gauges in 2040 and The Future of Food. The culmination of this work has resulted in Rethink X, of which he is a co-founder. Rethink X is a think tank to forecast the speed and scale of technology-driven disruptions across various industry sectors and their potential implications for society. Rethink X has a number of publications, including forecasts for transportation, food and agriculture, and clean energy over the next decade. His talk today focuses on similar themes and is entitled The Great Disruption: Disruptive Transformations of Energy, Transportation, and Food and Agriculture, and Implications for Society. We will be here afterwards for Q&A. And with that, I'm happy to let Mr. Seba take the stage.
All right, thank you, Madison. Let me see if I can share my screen. Okay, so not letting me.
It says that you're a co-host here.
You should
try one more thing. Okay, let's see if it works now.
Interesting. Still not.
It's something we should have tested beforehand, clearly.
That's right. We're not prepared. Yeah.
All right.
Okay. Yep.
Enable all participants to share. There we go.
Okay. Awesome. So you can see it okay, my presentation?
Yes.
Okay, excellent. Thank you so much for having me here today. And so I'm going to talk about what's coming over the next 10, 15 years, which I call the Great Disruption. And some of you had the chance to read Rethinking Humanity, which essentially the main insight is that, or one of the main insights, that in the 2020s and early 2030s, key technologies will converge to completely disrupt the 5 foundational sectors of the economy: information, energy, transport, food, and materials. And why do we call it foundational sectors? And that's because one of the things that came out of this study of 10,000 years of disruptions at the sector and at the societal level is that every time there is a order of magnitude improvement in any of these sectors, we get a radical change in society. And when we get 3, 4, 5 of these together, then essentially we get a transformation of everything about that society. And of course, the implications are dramatic for every single sector across the economy. And the one thing that we realized is that information is at the center of all of these disruptions. So let me tell you about what I'll talk about today. First, I want to introduce how disruption really works. Then I'll talk about transport, energy, and food and agriculture, how those are going to be disrupted, and some of the implications for society. So how does disruption really work? So this is New York City, 1900 Easter Parade. We used horses as our main means of transportation, we, humanity, for thousands of years. And here you see just one car. And just 13 years later, in a sea of cars, you see one horse. So this is how quickly disruptions can happen. And the horse transportation industry was a millennial industry, multi-thousand-year-old industry that got wiped out essentially within 20 years. So what a disruption is when new products or services create new markets and also destroy or transform existing ones. And this is important, that it's usually the experts and the insiders and the mainstream analysts who dismiss disruption. And more interesting than that is the idea that folks who were disruptors at one point in their life, essentially when they become the establishment, they start dismissing the next disruption. So how do you explain that Bill Gates, who was a disruptor in his day, in the 70s and 80s, essentially did not see or dismiss the 3 biggest disruptions in information technology: the cloud, the smartphone, and the internet over the last 30 years? And that's an important question. So this is how disruption actually happens. We live in an equilibrium. And by that, I mean, for instance, in transportation, we've had a similar value chain for the car for about 100 years. So that's the equilibrium. We've seen a lot of improvement in technologies, but by and large, those have been incremental. Cost curves. So there are always technologies that are improving at all times, and we'll get into all of this. What enables the big disruptions is actually a convergence of technologies. And importantly, convergence opens up a brand new possibility space if you're looking for it. And in fact, this is one of the reasons the mainstream doesn't get disruptions, because they don't look at that new possibility space. Entrepreneurs do, innovators do, but not incumbents. At that point, there are companies that enter the market and improve those costs in cost and capability over the following few months and years until that product or those products rupture the existing equilibrium. Essentially, they push the system out of equilibrium. And at that point, there are accelerators and feedback loops that enable an S-curve adoption of the new and a quick, essentially, collapse of the old. And the new crystallizes as the new system. And then we start all over again. So let me go into some of these. Cost curves. You know cost curves, we know Moore's law, which more or less says that computing improves about 2x every 2 years. So the Mac that I just bought about a month ago is already obsolete, right? When Apple came out with their new MacBook Pros last week and so on. They keep improving, but it's not just computing. It's essentially data storage, imaging, network capacity, and so on and so forth. And each one improves at its own rate, and it's both cost and capabilities. So in 2014, in my book, Clean Disruption of Energy and Transportation, this is what I projected for, this is the cost curve that I projected for lithium-ion batteries. And I said that by now, the capital cost of lithium-ion batteries would be about $150. And at the time, the mainstream thought that I was insane. I mean, many of them still do, but it's not going to happen. $150 is not going to happen, right? And in fact, we know that it already has. I mean, this actually has been faster, the improvement in batteries. So, but the point of making these kind of projections is not pinpoint accuracy, is to give you an idea of the speed and scale of disruption. But like I said, it's convergence that enables the big disruptions, what I call the phase change disruptions. So if you ask yourself, why did both Apple and Google come up with the smartphone the same year, around 2007? Not 2004, not 2010. That's because all the technologies that made a $600 smartphone possible converged that year, 2007. So the possibility space for the smartphone opened up. So any of 30 companies or 40 companies could have made it happen. But it was Apple and Google, two companies that had never built a phone before, the ones that actually made it happen, which is another lesson of disruption, which is that it happens from the outside. It's not insiders, it's outsiders who make disruption happen. So I follow a number of technologies that in my work, and this is not all, but in my work, I have looked at in terms of convergence and improvement rates and so on to see how they're gonna basically disrupt the world over the next 10 to 20 years. When possibility spaces open up, the possibility of business model innovation also opens up. So if you think of Uber or Lyft and so on, Uber got started in 2009, which is exactly 2 years after the smartphone came out. And this is not coincidental. That's because the possibility space for ride hailing opened up with a smartphone. And Uber went from an apartment in San Francisco to more bookings than the taxi industry in America inside of 7 years, just 7 years, which is how how quickly disruptions can happen. And as you probably have seen, also car rentals, the car rental industry is also collapsing due in part to ride hailing. So disruptions can happen very quickly because of business model innovation. this is also really important. Adoption happens as S-curves, never a straight line. So if you go back to the horse and the car, that disruption happened in America within 20 years. So essentially from almost nothing to 95% of passenger miles. But here's the key. The market share, the bulk of that disruption happened in just 10 years, meaning from about 10% to about 80%. That's the bulk of the disruption happened inside of 10 years, despite the fact that we built two new industries, auto and oil. We built a whole new road infrastructure. We fought a war and the meanest influenza pandemic in history. Does that sound familiar with the ongoing disruptions in transportation? That's because disruptions do happen in about 10 years. And in fact, we've looked at hundreds of disruptions across time. And whether it's insulin or coal or corn or car tires, hundreds of disruptions have happened within 10 to 15 years. And so S-curves, and the S-curves are, if anything, accelerating. So if you feel that things are happening faster and faster, it's because they are, right? And S-curves usually tell you that it's a phase change, and I'll explain what that means. But despite hundreds of years of evidence and that disruptions happen as S-curves, we still get mainstream mistakes. So the International Energy Agency every year, do a forecast of the adoption of solar. And it's a straight line into the future, straight line. And every year they're wrong by 20, 30, 40%. So they still do that. I mean, that straight red line is their latest, right? Which is just an extrapolation. But if you look at the green, that's reality. And it's starting to look like an S-curve of essentially the solar industry. But the same thing happens for the collapse. So if you look at coal in America, the US EIA has predicted a straight line every single year. But if you look at reality, which is the black line, the reality looks like an inverted S-curve, which is how collapse happens. So mainstream mistakes happen over and over again, which has led me to ask this question. And this guides a lot of what I do, which is, why do smart people at smart organizations with access to all the data consistently fail to anticipate or lead market disruptions? And the most succinct way to put it is the establishment mindset. It's the idea that the existing system, no matter what that system is going to continue into the future, and that changes are going to be linear, reductionist, and siloed. That you can draw a straight line into the future, which is what I call a linear mirage, and that what's coming is a one-to-one substitution, where basically you take the horse and the car would be a faster horse. That's what I call a faster horse syndrome, which is the one-to-one substitution, which works in many cases, but in most cases it doesn't. So that's because disruptions can be a phase change to a new system with new properties. So the car, as we know, was not just a faster horse. When you look at the car was 10 times faster, it could carry 10 times more goods or people, and it was 10 times cheaper. The car market was hundreds of times larger than the horse market ever was. So it was not a one-to-one substitution. And the new car market has totally different properties than the old horse transportation market. And in fact, if you look at the cascading ripple effects of that one disruption, it changed everything about the world in the 20th century. Geopolitics, politics, food, everything, cities. We built cities around the car, for the car, actually, not for people. in the 20th century. So these are what I call a phase change disruption, which means that everything about the system changes. And I talk about the faster horse syndrome. There's also the slower horse syndrome. Essentially, people who want to keep consuming what they do and add some kind of hybrid and so on. And this is the slower horse syndrome. And of course, tastes and preferences change with these disruptions. So if you ask yourself, what happened to all those horses that were disrupted in America? We ate them. I mean, not you and me, but essentially horses became the clean meat of the day. We started eating them. And what we're seeing today is also a behavior change away from the car. So the smartphone is already destroying the value of the individually owned car. Things that we used to need a car for, to own a car, we do online. Whether it's dating, movies, restaurants, and so on, we do online. So in a way, the smartphone is already disrupting the car. So it's not just a direct substitution, but also the ripple effects from other disruptions that are disrupting essentially everything about transportation. So again, we're in an equilibrium. We have technologies that converge and open up a new possibility space. Companies enter the market, push the cost and capabilities till they rupture the existing system, and feedback loops accelerate the adoption. So the new companies like Tesla and so on and so forth rises and the old crashes and the new becomes embedded. That's how disruptions happen at every level. So let me talk about the three disruptions, the transportation, food, and materials. Let me start with the disruption of transportation. So in 2014 in Clean Disruption, this is the cost curve that I predicted for the cost of an electric vehicle with 200-mile range, unsubsidized. I said that based on the improvement in batteries and manufacturing and so on and so forth, the world would see by 2021 or so, sub $30,000 EV with 200-mile range. Now you can imagine at the time how insane, and maybe you can't imagine, but at the time that sounded pretty insane. At the time, essentially the mainstream was forecasting that EVs were not going to make a difference in the market until the 2040s at best, if not the 2050s or 60s. This sounded positively insane, but again, it was what the data showed in the improvement cost. And of course, if you look at this, it says that by 2025, we would have a $10,000 EV with 200-mile range, which again, sounded kind of crazy. Yes, there is enough lithium. Please hold your questions to the end, but yes, there is. Today, you may have seen a Chinese company called Geely that essentially announced the $9,000 SUV with 200-mile range. So this is about 4 years ahead of my forecast, which at the time, just 7 years ago, sounded positively insane. And if this, again, if this forecast is right, there will be no more internal combustion engine automobiles after 2025 for purely economic reasons. This is not about the environment. This is about purely economics. But this is not a one-to-one substitution because electric vehicles their lifetime is about 500,000 miles with the million-mile EVs coming into the market as we speak from GM, from Tesla, and so on. That's up to 7 times the lifetime of an internal combustion engine automobile. So if you're Uber or Amazon and so on, you can buy one EV over 10 years and drive it 1,000,000 miles, or 7 internal combustion engine automobiles. It makes total economic sense for fleets today to go electric for purely economic reasons, right? Which is why companies like Amazon are already going all electric, because it makes total economic sense for them to do that. Another reason why this is not a one-to-one substitution, you can power your home with your EV and vice versa. So a 200-mile EV can store about 2 days of electricity for the average American home, 3 days with the Ford F-150, the electric one. 3 days. Try that with hydrogen or gasoline or whatever. So this is an additional value that the internal combustion engine doesn't have. And this changes everything, not just in transportation, but also in energy. And just to give you an idea, EVs could store about 100% of Canada's daily electricity demand already, right? 200-mile, 300-mile EVs. But of course, so that's the first phase of the disruption. So it's pretty much all over before the end of the 2020s. Phase 2 is when the autonomous vehicle happens, right? So, is it safe? That's the first question that many people ask. Are autonomous vehicles safe, right? Well, the Tesla Autopilot is not even level 4 autonomous. It's not even level 3. And it's already almost 9 times safer than the average human driver. Already 9 times safer. I mean, if we all used Tesla with Autopilot today, we could save 900,000 lives on a worldwide basis today. And that's not even level 4, right? So this is not safer in every circumstance. But the point is that these things are getting so much safer and safer than human drivers. I forecast that autopilots would be 10 times safer than human beings by 2022, which is just about what's going to happen. The point is that the improvement rate for autonomy is on an exponential basis. And the disruption, phase 2, is what I call transportation as a service, which is on demand, autonomous and electric, owned by fleets, not individuals, but fleets. So think about Uber, robotaxis, or Didi, or Lyft, and so on. And again, all you need is one level 4 autonomous vehicle that's ready and approved for us to, for the industry to be off to the races. So, if Daimler or Toyota says we're not going to be ready by 2030, it means they're not going to be ready by 2030. This is a computer on wheels, right? And we know from operating systems that only 2 or 3 operating systems are going to make it. So we need one, and then in the end, only 2 or 3 are going to survive. The day that level 4 autonomous technology is ready and approved, essentially the cost per mile of transportation is going down by about 10 times. 10 times has enabled a disruption every single time in history, every single time, right? On a purely economic basis. So 10 times relative to the cost of individually owned transportation. So essentially, we're going to stop buying new cars. And we're going to, essentially, the decision that we're going to have to make is, do I want to buy, to spend $50,000 in buying a new car over the next 5 years, or do I want to buy a subscription to Uber for $100 a month? That's the decision we're going to need to face. And essentially, TaaS is going to be 10 times cheaper than owning a car, any car, and 4 times cheaper than even the running costs of individually owned transportation. right? So Tesla is already saying that their robotaxi is going to cost anything from 10 to 20 cents per mile. So similar numbers to what I published in 2017. If this happens, level 4 autonomous technology, over the next couple of years, essentially 95%, not just the new cars, but of passenger miles will be electric by 2030. 95% of passenger miles will be electric. So the bulk of the disruption is going to happen over the next 10 years. And interestingly, the size of the fleet is going to shrink by about 80%. Why? Because we're going to have cars and vans going 100,000 miles a year, round and round, instead of individuals driving only 10,000 miles per year. So instead of us storing the car in parking 95% of the time, we're going to have fewer cars and vans going around pretty much all the time. And the implications are stunning, right? So in 2017, I forecast that the oil demand would go down by about 30% in the 2020s, and the cash cost would drop to about $25. And both of these things happened, by the way, last year, which again, it may sound insane when you first do the numbers, but both these things happened already. And now we're getting oil companies saying, yep, oil production peaked and we're going to reduce output. And again, they say it's because of climate, but in fact, it's for purely economic reasons. Russia already says that they already hit peak oil. And the implications for land use are also stunning. Those of you who are interested in urban renewal, because we're going to have far fewer cars that are going to go round and round, essentially 80 to 90% of parking space is going to free up in the cities. 80 to 90%. Again, this happened. 90% of parking was freed up during the COVID disruption last year. So the possibility that this would happen went from not going to happen to, yeah, it could kind of happen, right? And if I'm right that 80+% of parking is going to be freed up, the implications for urban planning are stunning. So in LA, for instance, I did the numbers for if LA parking was freed up 80%, you could build 3 cities the size of San Francisco in just the parking space freed up in Los Angeles. So we need to start making the societal choices as to what we need to do with all this space before the market actually makes it happen itself. Okay, so that's the disruption of transport. Let me talk about energy. Here's the question that I want to answer. Is 100% solar, wind, and batteries possible? Meaning, is an electric power system made up of only solar, wind, and batteries possible? And if so, is it possible by 2030? And if so, how much is it going to cost? So let's look at some of the numbers. Cost curves, solar, even the IEA has admitted that solar is the cheapest source of energy ever in history, unsubsidized ever, right? And wind is right behind it. Not only that, solar plus 4 hours of storage today is not just the cheapest source of energy, it's cheaper than the operating cost of coal, nukes, oil, and gas generation today. So even if you can build a coal power plant or gas power plant for free, just the cost to operate that plant is going to be a lot more expensive than the total cost of solar or wind plus 4 hours of storage. So essentially all of conventional generation is already obsolete. And of course, nobody could have predicted that solar would go down by 82%, right, since 2010. Well, that's the narrative in the mainstream. I did predict in 2010 that solar would drop by about 80 to 90% over the next decade. So again, this is not about pinpoint accuracy. This is about understanding what's coming, the speed and scale of the disruptions that are coming. And today, 90% of the generation projects in the US interconnection queue are either solar or wind. Everything else is pretty much irrelevant. Batteries are 98% of the storage queue, which again, this looks like the market is paying attention to actual costs. So we have a convergence of solar, wind, and batteries. And as I'm going to show you, the cheapest sources of energy are going to get 70% cheaper, which means that this disruption is inevitable, solar, wind, and battery, because the cheapest is going to get 70% cheaper. Solar, which went down 82%, is going to get 70+% cheaper. Wind, again, went down 46, is going to go down 43% by 2030. Battery, which went down by about almost 90%, we expect another 80% drop over the next 10 years. And by the way, there was a study published a couple of weeks ago that says that rooftop solar alone could generate as much electric power as the whole US generation infrastructure today. So just rooftop solar can double essentially the electricity generation in the United States. And the other interesting thing about this, and I'll come back to 100% SWB, is that solar PV is so cheap, it can be used as structural building material because it's cheaper than structural plywood. So there's a company in Australia building houses with solar as a structural material. Essentially, energy generation is free forever, right? And this is how things change. So it's not just about rooftop. Now it's about vertical solar as we go forward. So again, here's the question that I asked initially with my team at RethinkX. We looked at New England, California, and Texas. We looked at hourly generation, actual generation data of solar and wind, and also demand data, hourly demand data. We simulated batteries because we don't have that many batteries yet. And this is one of the key findings. Yes, there are thousands of possible systems, electric power systems that can be built in America and meet every single hour of demand, even those, February, winter, New England hours, every single hour of the year. And but it is not a one-to-one substitution, and it is not a linear trade-off. It is a non-linear trade-off between generation and storage. Essentially, what that means is that because storage is a little bit more expensive, you can over-generate solar and wind to get more storage, to pay less in storage. So the more you generate, the less storage you need, and vice versa. So a lot of the conversation about storage is here, meaning folks are saying that, if we substitute the existing generation system, we're going to need weeks or months of storage. Whereas, in fact, that's not true. That's not true if you look at it as what we call the clean energy U-curve. So this is the least cost system, which, as you can see, would need 4 times the generation capacity of the existing electric power system, 4 times, right? And if you build that 4 times over capacity, then all you would need across America is anything from a day and a half to about 4 days of battery storage to meet every single hour of electric power demand of the year. And not only that, a 100% solar, wind, and battery system is the cheapest possible electric power system if we start building it today and we finish by 2030. The cheapest possible in all of these regions. Now, I'll talk about these regions, but we've done also work after we published this. And the same thing applies for Brazil, for India, for Denmark, and for Germany. So this works, in hot areas in the equator, and also as far north as Denmark and Germany. In the US, it would cost less than $2 trillion to build a 100% solar, wind, and battery system. This does not include the network itself. This is all generation and storage. And like I mentioned, this is not a one-to-one substitution. This is not a case where you swap out coal and you swap in solar or wind plus batteries. The whole system changes. How so? Okay, so one of the insights, one of the findings is what we call superpower, which means super abundant, essentially zero marginal cost energy generation. And so what it means is that, when you overbuild, because we build the SWB system to meet that 1 hour, in Worcester where it's really, really, really cold and it's not sunny and there's no wind, you have to meet that 1 hour. Essentially what we're doing is overbuilding for the rest of the year. So this is the way, for instance, the Amazon cloud works. They overbuilt that cloud for the 5 weeks of Amazon purchases, right? Retail during the Christmas break. And they had all of this cloud that they had built for the rest of the year. And that's how they can rent out that cloud to the rest of us, because they essentially overbuilt that cloud. The same idea is applying or can apply to energy. So the rest of the year, we can generate up to twice the energy that the existing system generates, and all of this generation is for free. All of this is clean solar and wind energy generation, 93% of days. So super abundant. And this is disruptive, not just to coal, nukes, and so on and so forth. It's also disruptive to all forms of energy. So if you look at, for instance, Texas, the existing demand, this system generates, the blue is the existing demand, which is, electric power, superpower. So all of this incremental generation would be a lot more. So the lowest cost system would generate more than 100% free, clean, incremental energy. That's the lowest cost system. And if you use that energy for transportation when it goes electric, it can meet all of that. So look at this, and you can meet with the lowest cost system all of transportation when that goes electric, all of residential and commercial heat when those go electric. And if you invest an additional 20%, even a lot of the industrial heat, right? So it's disruptive, not just to electric power, but also transport and residential heat. In Texas, their lowest cost CapEx SWB system would need about 49 hours of storage, meaning that the outage that they would not have had earlier this year, because the system would be not just the cheapest, it would also be the most resilient. 2 full days of electric power storage means that even if all generation went down by a half, essentially they would be okay because they had 2 days of storage. So there is no need for seasonal storage. So the idea that we need weeks or months of seasonal storage goes by the wayside when you look at the actual evidence. All they need would be 2 days of storage. In Brazil, 1 day, in India, 1 day, in Germany, about 4 days. So there's no need for seasonal storage. And the other thing that, the other insight is that solar is about 9 times larger the capacity than wind in Texas, right? In Brazil also, and in India also about 10x, right? So as you move further north, it gets more to 1-to-1. But essentially in really sunny areas, the solar opportunity is a lot larger than the mainstream 1-to-1 would imply. Disruptive economics, I mentioned that. If you go from the lowest cost system and you add a 20% incremental investment, you could get anywhere from 200 to 300% superpower. So again, 20% incremental investment, 200% more power. This is more like information economics, not energy economics. We've never seen this in energy, and no form of energy can compete with this. So New England, essentially with an additional 20% investment, would generate an additional 210% superpower, which is just that 20% incremental investment would generate a lot more energy than the existing electric power system generates. So the economics are something that, you know, essentially energy cannot compete with. And just to give you an idea of the magnitude, in Texas, with a 10% incremental investment, they could generate enough power to essentially power every data center in the world, every Bitcoin miner in the world, and an additional 41 terawatt hours of energy. This is just the 10% incremental investment. So the idea of energy as a limited resource basically is going to be flipped to energy as a, you know, almost infinite resource. So we need to rethink everything about energy, from energy economics to protecting consumers, because, you know, generation assets are already stranded. Conventional generation assets are already stranded. So let me talk about the disruption of food following the same basically framework. And let me start with insulin. In the 1970s, insulin was extracted from animals. Essentially, you needed about 23,000 animals to extract 1 pound of insulin, which sounds medieval, but essentially that's what we used to do. And we still do that with animals, right? Big Pharma came up with essentially animal insulin, human insulin, which, even though it was healthcare, disrupted the animal insulin market in less than 15 years. So they went from essentially nothing to 95% inside of 13 years. That was a quick disruption. And we didn't need animals for human insulin. The way that they did that was using something that we now call precision fermentation. So, you know, beer fermentation, you know, you add grain and water, you ferment it with yeast, and you get beer. Same idea with precision fermentation. The difference is that you can design microorganisms or redesign microorganisms to produce pretty much any protein or organic compound that you can imagine. So instead of producing beer, you can produce proteins. And this is the technology that, like I said, was used by Big Pharma to start making insulin 40 years ago. Now, why is this interesting today, other than Big Pharma? Because biotech and information technology have already merged. So the difference between biology and information has already blurred. And this is how we got the mRNA vaccines last year. Because if you look at, for instance, Moderna, they call themselves a biology, a medicine, an information medicine platform. So if you look at biotech cost curves, they essentially make Moore's law look linear. And in fact, it does look linear next to, for instance, the cost of genome sequencing. It's just improving super exponentially. So let me talk about the disruption of milk. Milk, 3% of milk is proteins. Essentially, the cow, all it does is recycle water and ferment essentially proteins. 3%. So disrupt 3% of milk. You don't need to disrupt all of milk, but that 3%, which is the value actually of milk, and you disrupt the whole dairy industry. Now, how difficult is that? I'll give you one indication. A third of milk production is sold as dry commodity ingredients, basically to the protein bar and protein shake industry. Now, essentially that means that if all you do is disrupt protein bars and protein shakes, a third of revenues in that industry essentially go away. And we know from history that food ingredient disruptions happen very quickly, and they follow S curves, from citric acid to vitamin B to insulin and so on and so forth. And in fact, it can happen even more quickly. Pepsi and Coke went from all cane to all corn sugar inside of 4 years. 4 years, that's how quickly disruption can happen. And precision fermentation cost curve has improved by about 10,000 times since the year 2000. So 100 times per decade, compound. If it keeps going by this 100%, 100x per decade, and even if it slows down a little bit, essentially it means that precision fermentation proteins will reach cost parity with animal proteins by about 2024, 2025. That's about $10 per kilo. $10 per kilo. That's the magic number. And that should happen by about 2025, meaning that after that, the industry cannot compete on a purely economic basis. And it's not just proteins. I mean, it's a new system of what I call food as software. I mean, if you look at Impossible Burgers, I mean, they're like already in their version 3.0, 4.0, and so on. They improve their food as if it were an app, right? They take ingredients and so on and so forth, put them together, and there goes the Impossible Burger, right? So that's food as software. And this is a phase change to a new system. So it's not just a one-to-one substitution. I mean, all we use, 75% of our food comes from just 12 plants and 5 animals that we domesticated thousands of years ago. With all the technology we have, that makes no sense. And especially because the number of proteins in the universe is infinite, or possible proteins. And with precision fermentation, we can essentially create any protein that we want, millions of proteins in nature and others not in nature that we can design according to our own requirements or needs. And so it's not just food. Proteins can be used and are used in industry, in cosmetics, materials, in health, and in food. So the cost curve of precision fermentation is being driven regardless of food, is being driven by the needs of all of these industries, which tells me that it's going to continue and if not accelerate. And this is not just a bunch of startup companies. Larger companies are already getting into this market with what they call, brewed proteins and so on and so forth. And so basically, when you look at the cost curve of proteins, precision fermentation proteins are going to be 80% cheaper than dairy proteins by about 2030, and 10 times cheaper by 2035. So we see this industry as bankrupt without a single consumer changing their behavior. So big picture, this is the second domestication of plants and animals. This is not just, a one-to-one substitution. This is a totally new system. And the same thing that I said about milk applies to meat. And if you, have tried the Impossible Burger, you know what that looks like. But in the end, the cow industry is the most inefficient food technology on the planet. It takes 25 pounds of feed to produce 1 pound of food. That's insane. With precision fermentation, basically it's up to 100 times more land efficient than the cow. Livestock uses 40% or so of land in America. 40% of land in America goes to livestock, not for people. And again, you don't need to disrupt the whole thing. Just 2% of Impossible Foods burgers are, precision fermentation proteins. And that's really all it takes. And it's not just cows, it's eggs, it's pork, it's fish, it's chicken. All of these things are being disrupted with both precision fermentation and also cellular agriculture. And many countries around the world are already approving these foods. So what we see, again, for purely economic reasons, is that the need for cows is going to drop by about 50% by 2030 and about 90% by 2035 with this disruption. And the implications of this are, look at it. In America alone, the disruption of food is going to free up 485 million acres of farmland, which is a landmass the size of the Louisiana Purchase. Nothing like this has happened since 1886 in America. On a global basis, the food and ag disruption is going to open up 2.7 billion hectares of land freed up from animal agriculture by 2040. That's the size of the US, China, and Australia put together. So again, these are the decisions that we need to make on a going forward basis. If this disruption does happen, as I say it will, essentially we're going to have, what I'm calling the Great Land Liberation. Basically, we're going to take it back. What do we do with all this land? It's going to depend on us. Climate change, just 8 technologies that I've talked about: solar, wind, and batteries, autonomous, electric, and on-demand, precision fermentation, and cellular agriculture. 8 technologies that are in the market today or just about can reduce emissions by 90% by 2035 by the market for purely economic reasons. So the whole narrative about climate change being a hard problem to solve is really not, it's more about mindset, not about reality. In reality, if all we do is accelerate these disruptions, we can actually solve climate over the next 15 years. Materials footprint is going to shrink, actually, not go up. So I'll let you digest this later, but if you put together the three disruptions, they use the production of virgin, the demand for virgin steel for pipelines, oil tankers, fishing fleets, cars, and so on, are going to peak and then fall dramatically, basically like S-curves, right? And steel is recyclable. So what's going to happen is that demand is going to fall at the same time as the supply of recyclable steel is going to essentially explode. So my team sees that we're going to actually see virgin steel production crash over the next 10 to 15 years when you put together all of these disruptions. For society, because the cost of food, energy, transport, and so on are going down so dramatically, we see the cost of the American dream in terms of energy, what we consume today in America, energy, transportation, food, and so on, is going to go down to about $250 a month in the 2030s, $250 per month. And today it's somewhere around $20,000. So essentially, we can end poverty, inequality, environmental destruction. And again, all of these on a purely economic basis. But this is not going to happen automatically. We'll need to make choices again. But the possibility space for this happening has already opened up. On the downside, we see increasing instability over the next 10 to 15 years. So all of these disruptions mean that all of the industries that built, the 20th century, if you will, are being disrupted. So essentially that's causing all kinds of instability, social, political, economic, and so on and so forth. So while we build the new, we're having instability in the old, right? And some of what's going on in the world today, you can explain with this slide. Essentially, the idea that we're going into the new at the same time that we have not yet built. I mean, we're going into a new system, but we still have not built it. But the old one is collapsing before our very eyes. So we have choices to make. And we can talk about choices forever, but in fact, we need to do three things. We need to rethink everything. The future is not a linear extrapolation of the present, as we have seen, right? All of these things are complex adaptive systems. So we need to rethink everything. It's not what the mainstream says. It's not what smart people necessarily say. Just do the numbers, right? We need to protect people on a going forward basis, not businesses or industries, legacy businesses, because we know that they're collapsing. We just need to make sure we protect people so that we don't increase instability. Two, we need to accelerate the new. We need to build out the new systems, right? If we want to end climate change or solve climate change and poverty and so on and so forth, we need to accelerate the new system of production. And we need to bridge the journey. And what does that mean? We need to, as weird as it may sound, we may need to subsidize coal and gas and so on while we build the new, right? And this doesn't sound right in many ways, but what we're seeing, for instance, in the gas market is an indication of the instability in the existing system, that we have not built the new, but the old one is already obsolete. And so it essentially we need to hold the existing system while we accelerate the new. And the idea that the new system is not another industrial revolution. So it's not going to be a breakdown. It's not going to be centralized. It's not going to be about huge physical flows. It's going to be the more like internet. I mean, think about the internet of energy, the internet of transport, the internet of food. It's going to be a bottom-up creation-based system where design and development, intellectual property is global, technology is global, but production is going to be local with local materials as much as possible. So we need a new mindset to think about all of this and to develop a new way to organize ourselves and govern ourselves and manage this new creation system while we build this new system and we transition away from the old. And to wrap it up, this is not a transition of energy, food, materials, information, and so on. This is not led by governments. This is a technology disruption. It's happening for purely economic reasons, and it's in fact happening despite many governments and many industries who claim otherwise. Thank you.
Great. Thank you for that. That was really interesting. So we have up until around 2 o'clock for Q&A. We do already have a couple questions in the chat, one of which I believe you already acknowledged a little bit on whether or not we have enough lithium in order, like, for the electric vehicles to that transition to occur, that disruption to occur. So
do we? Yes,
do you have,
yes, we do.
Yeah.
I mean, yes, we do. We have plenty of lithium for this known lithium. The lithium that we know is there. There is plenty. I mean, there's all kinds of narratives that say otherwise, but I haven't seen a single credible study that says otherwise. And that's what we know. What we, the kinds of things that we're discovering today. Like mining the Salton Sea, for instance, or newly discovered lithium in Nevada and so on and so forth, can only increase the supply of lithium. The other thing that I would caution you about is that lithium-ion batteries are the winning and will be in the foreseeable future the winning technology for battery storage. But it doesn't mean that in 10 years, the same chemistry, or even 5 years, the same chemistries that we use today are going to be the winning chemistries. So the chemistries have changed dramatically just over the last 5-10 years. We don't use as much cobalt. We don't use as much. So cobalt has gone, as you know, from, just look at Tesla batteries. And they're pushing down to almost zero cobalt and substituting with nickel, for instance. And we also have new battery chemistries with solid state and this and that, and table salt, right? So there are a lot of new chemistries that we have that may or may not use lithium, right? So the answer is twofold. One, yes, we have enough lithium, but two, don't think that what we think of today in terms of material needs is what we're going to need in 5 or 10 years. 5 years maybe, but not 10.
Brady, thank you. And we have one other question in the chat along those lines, kind of similar from Chris Masser saying, with geopolitical concerns, could you comment on the dependence of African mines to support the energy storage needed to support this?
Can I comment on the dependence on African mines?
Yeah.
I can. What do you want to know? What specifically? Most of the lithium we consume today comes from Chile, Australia, and Argentina, right? Most of the cobalt comes from, the Congo. But essentially the sad thing over the last few hundred years, is that in what I call, if you read Rethinking Humanity, is the age of extraction, right? We have colonized many regions in order to extract and exploit both resources and people, right? And that's a sad legacy of the extraction age. As we go into the creation age, essentially, like I said, we're going to need far less of a material footprint that will come from everywhere, not just, essentially, Chile or Bolivia or Congo or and so on and so forth. And that is good and bad, right? In many ways. But I think the important thing to realize is that the countries that have one of the main insights is that if I'm right, and we're on the cusp of a major transformation of humanity, it means that in 20 years, the countries or the regions that dominate the world are not going to be the countries or regions that dominate the world today, right? So we're going to have a flip, just like we've had in the past when, Uruk collapsed and then Babylonia came up, and then they collapsed and Egypt came up, and then they collapsed, and we had the Mediterranean powers, and then Rome, and then they collapsed, and then Europe was, the worst place on earth for 1,000 years, and then they rose to dominate the world. The same dynamics is happening today, and what I see is that the countries that dominate this creation-based system of production and do the right thing in terms of reorganizing themselves are going to lead the world instead of 10, or at least be the dominant societies within the next, say, 20 years. Not China, not the US. And that flips the conversation. Disruptions, both at the corporate level and at the societal level, happens from the edge, not from the center. So what I would ask you to do is think about what societies can leapfrog by building this new infrastructure, can totally leapfrog the West and become the leading societies of the 2040s. That's how I would frame the kinds of choices that we would want to make. Does that make sense?
Thank you.
Yeah.
Great. Do we have any other questions? Great, Professor Bell.
Great. So since this is a materials and manufacturing seminar, I wonder if you can talk a little bit about what you see coming for future manufacturing technologies and opportunities in specific materials areas we should look for.
Yeah. So again, the opportunity space. Every time we had disruptions in transport, in energy, and information, and so on and so forth in the past, we have seen. I talked about the car and the horse and so on. We have seen transformations in. It has opened up the possibility space for new materials and new manufacturing methodologies and so on and so forth. And that is exactly what we're seeing today. So if you look at Tesla's new factories, for instance, some of their processes are about 7 times more efficient than the existing OEMs in the car industry. That's huge, right? That's a little bit like Ford. I mean, Ford's main distinction 100 years ago was not the car itself, was manufacturing, right? That they flipped the manufacturing model and made it 10 times faster and more efficient and so on and so forth. So some of the technologies that are going to change materials, one of them is, of course, precision fermentation. Essentially the idea that we can make any protein that we want, even those proteins that are not in nature. And with proteins, billions and trillions of them, we can essentially start from functionality and durability and so on and so forth, and work backwards and create a protein that essentially meets our, any need that we want. So that's one area that I see. And, spider, for instance, proteins is just the beginning. I mean, just that's just one thing. There are companies that are making, proteins to substitute for anything from oil to wood to, so we see everything being basically disrupted from the ground up. So 3D printing, of course, you already know what we can do on a, from a nanotechnology perspective and so on. But the big picture, I think, is that we're going from extracting from nature and breaking it down, right? So we extract massive amounts of steel or the iron or aluminum and so on. We break it down, we chop it up, and we boil it, and so on and so. And out comes a car, right? To a point where we're actually making those materials with precision fermentation, for instance, with nanotechnology, and so on. And in that case, if you think about it, in that case, then we are going the making the materials and manufacturing the products become one, right? So instead of several steps in manufacturing, essentially you can design a process to both make the material and the product at the same time. Does that make sense? So that is, the big picture of what's coming, and using local materials as much as possible. Did I answer the question?
Yes, thank you.
Yeah, of course.
So I kind of have a follow-up to that question. So how do you think that that's going to impact how we manage our waste and how we manage like end of life of products?
Yeah, so those are societal choices. How we manage societal, end of life products. The market, sadly, right? The market is a very powerful thing. It's a really powerful force, but the market itself doesn't care, as we know, about the waste that it produces. So those are societal choices. If we want what's called the circular economy and so on and so forth, these are things that we need to choose as a society. So, I talk about the market being able to solve climate over the next 15 years, and that is true. But we need it. It doesn't mean that we don't regulate it. Does that make sense? Having said that, because all of these technologies are a lot more material efficient and less wasteful, right, than the existing system of production in and of itself, that means that at worst, we're going to get 10 to 25 times less waste than we do today. If all we do is, use these technologies, we're going to get a lot less waste. That may not be good enough. So we need to actually prepare for this and make the right, regulations from the bottom up to make sure that we regulate all of this end of life thing as a society. Does that make sense?
Yeah. Yeah, I guess my main concern with that would be, since there's still a lot of studies being done on like what the environmental impacts are of these nanomaterials and nanotechnologies.
Yes.
And as we make materials more and more specific, and
Yeah,
might introduce more difficulties in recycling. So
yeah. Well, there are a lot of opportunities opening up to do that, right? There are companies. JB Straubel, right, one of the co-founders of Tesla, as started a company to reuse and recycle batteries. That company is already worth billions of dollars, which means that there are investors who think that it's a multi-billion-dollar opportunity. There's a company in California, in Southern California, that's taking batteries. Just taking the whole, battery from Nissan Leafs and using them for grid storage. Very little change, right? So when we talk about batteries lasting 10 years or whatever, it doesn't mean that they're not usable, right? I mean, when we talk about the cycle and life of batteries, it means that it degrades from about 100 to 80%. It doesn't mean 0%. You can still reuse those batteries for the grid for decades and decades and decades. And then, of course, you can recycle and so on and so forth. So you can do all of these things. And in fact, companies are already doing that. But I agree with you in that we need to regulate that.
Maybe, thank you.
Yeah.
We have a couple more questions in the chat. So first one is from Mintasir, saying that we see a lot of market and technological disruptions also end up having labor market impacts.
Yes.
How do you think we can best protect workers in a way that still enables disruptions to proceed?
Yes. That's an awesome question. And which is why in the end of my presentation, I said, the number one thing we need to do is to protect people, right? So, we should, just like we did during COVID, not every country, but just like we protected people during COVID, we should see what's coming in the 2020s and 30s as one massive disruption where we need to protect people. We need to, give pretty much everyone access to healthcare, capital, not just financial capital, but social capital and educational opportunities and so on. So, because it's not just jobs that are disappearing, it's all industries, right? So we need to retrain essentially pretty much everyone over the next 10 to 15 years for what's coming. So rule number one, protect people, not coal industry, coal miners, not oil, industry, oil people, right? And retrain them for the new opportunities. So for instance, in the food and ag report, we calculated that just for food, precision fermentation in America would create about 1 million jobs, which is about the same number of jobs as would be lost in the food, in the livestock industry, and in the industries that serve that livestock industry. So basically we can generate about the same number of jobs, if not more. The problem is that the jobs, the disruption, the collapse happens up front, and the rise of the new takes 10 years, right, or 15 years. So we need to bring people along so that we can retrain them as we build the new, and that's what we need to do. So it's not just give them money and go away. It's bringing them along. And the other thing is that we need to be cognizant that whole regions are going to be affected by this. So this is not, just like, the disruption of cars affected Detroit, right? A lot more than it affected, the rest of America. We see the disruption of livestock affecting the Midwest disproportionately, right? So we need to make sure, and we need to know that upfront so that we can bring the programs to help them transition into the new. How? Not all new jobs are going to be high-tech jobs. In fact, for instance, with precision fermentation, we see that fermentation farms will be the new food farms, right? So fermentation farms don't need high technology training, right? So pretty much those can be where the livestock industry is today. Again, we need to prepare for that. And if we do, we would invest in making that infrastructure happen upfront, because the market is not going to make it happen in those regions. The market is going to make it happen close to where the demand is, where it makes more economic sense. Does that make sense? So protect people, right? And protect communities. not industries and not companies.
Thank you.
Yeah,
One more question in the chat.
yeah.
Statistically, how do you count the subsidies or tax factors towards solar or wind or electric vehicles, as there are various types of subsidies that's easy to double count or miss? Also,
Yeah.
what data visualization software do you use to create these amazing data sets?
Yes, thank you. So all the numbers that I do are unsubsidized. Essentially, the numbers that all the numbers that you saw are for unsubsidized everything, unsubsidized solar, batteries, and so on. So this is the cost of production. Are there, subsidies embedded and so on? I do my best, and my team does its best to, take out potential subsidies, right? So in the end, I say that unsubsidized solar, wind, and battery, for instance, are going to disrupt subsidized coal, gas, nukes, and so on and so forth, because those subsidies are going to go away. But again, the numbers that I use to do, basically these calculations are for unsubsidized solar, wind, and battery. What was the second part?
What software do you use to create these data visualization sets?
Interesting. Yeah, I don't know. I don't do the visualization myself, but I can get back to you on what our graphic designers use.
Awesome, thank you. Do we have any other questions? Alrighty, well, I have a couple more.
Yes.
So I guess one of them is like, what other disruptive technology? But what other disruptive technologies in other sectors do you see might come up? And also, like, would you count cryptocurrency as a disruptive technology? And do you think that that's going to have like any lasting impact on any of this?
Okay, sorry. There was audio feedback, but so I think you asked about other technologies, and also did you ask about cryptocurrencies? Is that okay?
Yes.
Got it. Yeah, I mean, I listed some of the technologies that I followed, and there's a whole number of technologies that I follow. And in fact, some of these, precision biology, for instance, includes several technologies. So it's a group of technologies from gene sequencing to, and I also add, blockchain is super disruptive, right? And wind, and information technology, everything. All of these disruptions in many ways are driven by information technology. So anything from AI to communication to computing to information technologies in all ways are super disruptive. And so blockchain is super disruptive. Cryptocurrencies are one use of blockchain, and I don't want to necessarily, and it's the one use that is getting a lot of, basically media and so on and so forth. And, Bitcoin is worth already $1 trillion. So I'm not gonna, argue against cryptocurrencies, but the way that I see the technology improving, essentially within 10 years, all of us are going to have our own currencies, right? So essentially think about, blockchain technology being an overlay over TCP/IP, over the internet. Not quite substitute, but maybe an overlay where contracts happen, where, in this new world of this creation-based production system, where, for instance, I'm in Accra and I want to produce a certain protein that somebody in Sydney had designed, or somebody in Worcester designed. Which protein do I download, right? Who do I trust to produce my food or my material? when I brew it in Accra. Or vice versa, right? So trust in a world of networks. It's going to be networks of networks of networks. Trust is going to be a big thing, right? And we're going to need new governance systems, new management systems that, in my opinion, can only be done with blockchain, right? You know, our accounting system that we use today has its roots in the 1300s, double entry accounting, and that helped with the rise of Europe, right? Today, in a world of networks of networks of networks, we have the possibility of doing, for instance, triple entry accounting, right? Why triple entry accounting? Because it's a way in which you can build trust into any system. Does that make sense? So for me, trust, contracts, new ways of governance, new ways of managing are a lot more interesting than currencies. Now, it doesn't mean that currencies are not, I mean, they're interesting, right? But all of us are going to have currencies, all of us, right? Just like all of us have Facebook pages or, you know, Twitter pages or whatever, we're going to have currencies. So what does the world look like when there are 8 or 9 or 10 billion currencies? That's what I would ask you, right? So instead of saying, oh my God, you know, which one of these 5 currencies that are worth $1 trillion today is going to win? Well, the better question is, what happens in a world with 10 billion currencies? Are we going to use Facebook currency, Apple currency, right? You know, are we going to use Seba currency, right? Trust is going to be a big thing there too. So when we think about blockchain, I would think about essentially an overlay to redesign management, governance, and so on and so forth, and enable a new system of trust. Does that make sense? And that's what I would think about rather than the narrow, important, but narrow view of cryptocurrencies.
Thank you.
Yeah.
We have another question in the chat related to the earlier one about not accounting for subsidies. And so the question is, do you think waiting for the market to adapt alone during the transient pre-crystallization stage is more favorable than pushing for government subsidies to accelerate the rate of disruption? What are the arguments in favor or against either option?
Interesting. So, I mean, you know, me personally, I think that the government should get out of the energy business and it should get out of the transportation business, meaning that the best thing that the government can do, I mean, especially in energy, and in these three, right? Transportation, energy, and food, is get out of the way, is to regulate intelligently, smartly, open up these markets to competition and to innovation. And I'll give you an example. So not subsidized. The biggest thing that the government can do, let's talk about the US government, can do to accelerate the disruption of energy and transportation actually is to grant individuals the right to generate, store, and sell electricity. If all of us, I mean, if you think of electricity, if you think of electrons, the way that we think of, you know, information, bytes, or even atoms, in the sense that we can buy and sell pretty much anything on eBay or, you know, online today. We can publish anything, information or atoms, but we cannot trade energy. Why not, right? Why not? The answer to that is that the electric power system, when it was conceived 100 years ago, 120 years ago, it lent itself, the technologies that we had lent themselves to a monopoly, right? Centralized generation, command and control out there. Somebody needed to build the whole infrastructure and so on and so forth. But that does not apply today in a world of distributed generation and storage. So if all we do, the US government or the state, is give me and give every homeowner and corporation the right to put up my own solar and batteries, power my own home with my own EV, essentially it already makes sense for tens of millions of Americans to do that today. And that would accelerate the demand, that would accelerate the installation, that would accelerate the S-curve and so on and so forth. So when you ask about government basically helping this along, it's not subsidies, right? So you need to think of this as a system, not as a linear view of the world. So where are the leverage points in that system where essentially I can do a couple of things that can accelerate the whole market? Does that make sense? So yes, we need regulation. No, we don't need subsidies. Yes, we need smart regulation. We need to break up the utilities to the point where anybody from Tesla to Vivint to GM can generate, store, and sell electricity on our behalf, right? For instance, where I can sell to my neighbors, just like I do on eBay. I don't, but you know what I mean, and so on and so forth. So we need government smart regulation. We don't need subsidies, not as of today. I'll add one exception. We do need to protect people, right? And we need to protect the demographics, the folks that cannot afford to do this for transportation and energy and so on. We can never forget that also the role of the government is to make sure that we have equity and fairness and so on in the marketplace. So again, the number one rule is protect people, always, not companies, not industries. Does that make sense?
Thank you.
Yeah.
Do we have any other questions? Right, Mr. Powell.
Great, thanks. Yeah, I don't have a hand raised in my client here, so I have to raise it on the screen. So I don't know if you've followed the work of Alan Savory. He has a TED talk about greening the world's deserts, or at least stopping desertification by having livestock play the traditional role of, not traditional, the biological or the ecological role of herds from thousands of years ago, pre-human. So he seems to say, or to imply that that's not just a way to raise meat, but that it's important or essential to keep nutrients and things in the soil. I wonder if you could comment a little bit on that, about how that would relate to protein or precision fermentation for producing protein, that way of producing animals.
Yeah. So interestingly, when you look at the disruption of energy, it turns out that it's going to flip the regional advantage from European, American, northern countries to countries that have essentially the possibility to create really, really cheap and abundant superpower, right? So if we start with that, with the idea that countries from Brazil to India to Saharan countries and so on, which essentially didn't have or don't have an abundance of coal and so on, or oil and whatnot, which means that they were left behind in the Industrial Revolution. Now they're going to have sub 1 cent per kilowatt hour energy with the possibility of superabundant energy. So what can you do with all of this energy? For less than 1 cent per kilowatt hour, you can produce essentially all the food that you want, in any country. Essentially, it means that any Saharan country has all the energy they need to produce all the food that they need, as long as they have water. And if they don't have water, they can actually desalinate it, because again, it's going to be free energy, which means that desalination, which is mostly the cost is energy. You're going to have free land, desert, free energy, free water. What can you do with that? All the food that you want in the world, right? And precision fermentation is 100 times or so more land efficient than the cow, 100 times. Why would you use a cow when you can use, right? Basically, the cow is just a fermenter, right? It's a bioreactor. It's a very expensive bioreactor, right? So instead of using the cow, let's use precision fermentation, right? To produce essentially everything that we need. Does that make sense?
Sure. Well, I think, yeah, Alan Savory would answer that question. That the answer to that is because we would use the cow because animals have been, the interaction between animals and a lot of these ecosystems has been important to maintaining the ecosystems and keeping carbon in the soil. That's a reason to continue to
I understand that, and I would want to see the data, right? I want to see the data as to, nobody prior to me publishing or us publishing the climate report had even considered that 2.7 billion hectares of agricultural land would be freed up over the next 20 years, 2.7 billion hectares. So the real question is, what can we do in terms of reforestation, afforestation, and so on and so forth with that 2.7 billion hectares? To me, that's the most important question, right? Traditionally, farming has been the biggest destructor of biodiversity on the planet, right? So the idea that we want more biodiversity destructing, animals to fix what they're destroying, it's incumbent thinking. You know what I mean? It's essentially, let's keep the system as is. Let's use these, 9,000-year-old technologies to see how, it's a Band-Aid, in other words. Does that make sense? So we calculated that, with the opening up of, freeing of land, that land can not just increase biodiversity, which, as we know, is just on its knees, but can also suck up more than 20% of climate greenhouse gases, inside of 15 years, right? On a going forward basis, 20%, maybe more. So I have never seen any cows that can do that, right? And, if anyone wants to show me how a cow in the desert can suck up, 20% of greenhouse gases, then I want to see that data. Make sense?
Yes, thank you.
All right, we have another question in the chat. Referring back to allowing for individual power storage and generation sales. So for that, are we missing out on cost reductions via economies of scale when we don't centralize? It seems like decentralizing generation and storage may make the transition slower and favor those who can afford the newer technology.
Right. So there is something that I didn't mention here, something that I call God parity. In energy, the energy industry has used something called grid parity to measure when the cost of self-generation is at or below the price that we pay for energy. And that's interesting, but what really can disrupt markets is what I call God parity, which is when the cost of self-generation is below the cost of transmission, so that even when you generate at zero in your centralized, which is going to be possible, right, with SWB, when you add the cost of transmission, that cannot compete with self-generation, right? In many countries, that is already happening. So in Australia, rooftop solar is something around 6 cents, but the cost of the grid is about 12 cents. So in that case, folks go solar for their, not just individuals, but companies go solar for purely economic reasons, right? I mean, when it makes sense to them because of this green, not the environmental green, but this green, then they'll go solar, and then they'll go, with batteries and so on and so forth. Most of the cost of rooftop solar today, at least in America, is not the actual technology, it's regulation. And it's, the tax that, not just the tax, but it's local regulation, it's federal regulation, it's the monopoly regulation, and so on and so forth. We can cut the cost by, take your pick, 50, 60, 70%, the actual cost of self-generation by taking out all of this, regulatory and monopoly taxes. So to your question, so essentially, this means that we're all going to go with self-generation when it makes economic sense to us. Now, having said that, your point about can we get fewer, is the cost of central generation lower? Yes, it is, but it's also more fragile. The system that we have today is very, very fragile, right? You have, a forest fire 1,000 miles north of here, and San Francisco doesn't have energy for a week, right? Our system has many single points of failure. Again, when we built the system 100 years ago, that was the way it was. But on a going forward basis, what makes sense is not just a fragile system with very expensive networks, is resiliency, right? Resiliency. If scientists, climate scientists are right, and we're starting to see this, and we're going to have a lot meaner weather events, forest fires, and so on and so forth. Resiliency, local resiliency, where everybody can generate and store their own energy, is going to be a lot more important, right? So it's not purely economics, it's resiliency. And an example of that is that data centers process technology a lot cheaper than we do at home, a lot cheaper. And yet we all have a computer and we all have an iPhone or a smartphone. Why is that? Why don't we just have a dumb terminal like they used to have in the 1960s? Because the cost of information processing is a lot cheaper out there. Does that make sense? The same thing applies for energy. We want resiliency at home. We want to produce our own information, and that's why, and store our own information at home, which is why we have iPhone, and so on and so forth. Does that make sense?
Yep, thank you.
Yeah.
We have about 5-ish, 10 minutes left. Do we have any final questions? Okay, Professor Bell.
I've always got more questions. I'll defer to others, but if there aren't any others, go ahead.
Yeah.
So for a lot of these technologies, whether it's solar and batteries or electric vehicles, well, they're not really transportation as a service, but for many of them, there's a higher upfront cost with savings down the road, and therefore access or preferred access seem to be a function of access to capital and credit score. I wonder if you can talk about how you get these technologies in the hands of people who don't have the credit score, the income, the kind of equity issue that we talked about earlier.
Yeah. No, I mean that's a great point. So essentially, pretty much everyone who owns a home today has access to finance to do solar and batteries and so on. I mean, maybe not everybody, but if you have mortgage credit, this is a incremental addition to what you already have, right? So that means that pretty much 100 million Americans or American families or so who own homes and so on have access to this finance. And basically that is nowhere near the penetration of solar and batteries and so on that we have in America. I mean, we have about a 50x growth to go before we get to that point, right? So finance is not the main impediment to the adoption of solar and batteries. Utilities are, monopolies are, right? If you talk to solar companies, they will tell you that, right? That utilities are the main impediment to America going solar and batteries and so on and so forth. Now, there are folks who do not have access to credit, who don't own a home, who rent, and so on and so forth. And we need to give them access also to credit. So one of the things that I advocate is new asset classes, right? So back to the government. If all the government does is make solar, the US government, readable, meaning today, for instance, companies can buy and sell properties using real estate investment trusts, right? They can buy an apartment building, a warehouse and so on, but you cannot buy solar using a REIT, which makes exactly no sense. REITs can be used to finance an asphalt roof, but not a solar roof. How insane is that, right? So if all the government does is make solar readable, right? So that it's on the same footing as, essentially asphalt roofs, for instance, then that would accelerate the disruption of solar and so on and so forth, and give access trillions of dollars of cash that is sitting in the market that would love to get into solar and batteries and so on, but can't because solar is not readable. Does that make sense? So we do need to, we don't need magic and regulation to give everyone in America access to the financing needed to do solar and batteries and so on and so forth. Does that make sense?
Yes, thanks. Yes.
No more questions?
Guess I always have more questions. So, let's see. The size of civilizations has been growing since from Babylon to Rome to, I don't know, Holy Roman Empire or the United States or what have you, based on communication and transportation technologies. It's arguably the size of the globe at this point. You've talked about civilizations rising and falling. I wonder if you could talk about what forces or civilizations rising and falling, similar to technology transitions.
Yes.
What does it look like if a global civilization gets disrupted?
Yeah, good question. So what we found when we looked at history is that anytime that we had an order of magnitude improvement in these 5 foundational sectors, right? Food, energy, transportation, information, and materials. Anytime we had a combination, and usually they combine and converge and so on, we had new civilizations rise. Interestingly, though, so yeah, we went from foraging to the first proto cities and agriculture and so on, to Uruk, arguably the first modern city of 10,000 people. And then they went on and then they collapsed. And then we had Babylonia, and then we had Egypt. Thebes went up to 200,000-300,000, and then they collapsed. And then Rome went up to 1 million, and they collapsed. And then interestingly, Europe, for a long time, the largest city in Europe was about 50,000 people. Now, what the largest city, the reason we used the largest city as proxy is what we call societal capabilities. So societal capability is essentially the ability to give a high number of people access to everything that we need: food, shelter, transportation, information, and so on. And up until 1800, when essentially most of energy was, animal energy and human energy, that translated into a bigger population. So the societies that led in the past were the societies that could essentially take these technologies, these 5 foundational sector technologies, and importantly, it was not just about technology. The societies that from Uruk to Egypt to Rome that actually went up to the next level of population and world domination were the societies that changed the organizing system. What does that mean? It was the way their belief system, the way they looked at the world. It was management. It was, for instance, Rome introduced adopted the idea of the Senate for the first time. That was an innovation at the time, right? They introduced the idea of the Republic, which was an innovation at the time. Now we think, the US Republic and the US Senate, they're 2,000 plus years old, right? And it turns out that it was all of these governance changes and the changes in belief systems and the way of managing the world that in combination with these technologies, that's what allowed these societies to rise, to break through, and not their neighbors. So why? Everyone in the Mediterranean had access to these technologies. Carthage, for instance, right? Greece, and so on and so forth. But it was Rome that actually rose to 1 million people. And that's because they had that fit the organizing system, that fit the technologies in the 5 foundational sectors. So go forward to today, when we're on the cusp of a new production system, right, for food, energy, transportation, and so on. And essentially, all of these technologies are global. Precision fermentation, solar, wind, batteries, autonomous. I mean, they're global, right? I mean, no single country has dominance of any of these technologies. So what is the society that's actually going to break through? Basically, accelerating the system of production has to be done, but also we need to create a new organizing system. And what that is going to look like is not clear, right? So I can tell you some of the fundamentals, right? I call it the age of freedom, right? And it's all going to be networked, local production, global design and development, and so on and so forth. But the details have to be worked out. It's a new way of looking at the world. It's a new way of, does that make sense? So on a going forward basis, we need to design both the production system and the new organizing system in order for this new society to rise. Now, I think one of the things you are asking, or may have been implied, is, does that mean that the world population is going from 10 billion to 100 billion, which it has done every time? No, that's not the answer. Okay, if that's not the question, then I'm not going to answer it, right? But in the past, you needed, you needed a new production system and an organizing system to manage a higher population. And if you could manage a large population, you could also manage a large military, right? So Rome was powerful, not because it's military, which is what you see in the media, right? They had a great military so they could run over everybody else. No, it's the other way around. They had a powerful military because they had a powerful organizing system and technology. Does that make sense? So what we've seen is whoever dominates and has, you know, the societal capabilities to build a world of, you know, to give a higher quality of life to a higher number of people, they're also the ones who can organize bigger, stronger, more powerful armies. Does that make sense?
Sure. Yes. Thanks. Okay. It's just past 2 o'clock here and 11 o'clock there. So I have to run off, but this is a good time to wrap up. Then let's thank our speaker again. Thanks very much. I really appreciate your coming to talk with us today, and spending a good couple of hours. And as we discussed, is a very busy time at RethinkX. So
it's my pleasure. Thank you for having me. Thank you for having me.
Great. All right.
Cheers.
Okay. All right. Bye-bye.
Thank you.